projects. In this video, we are going to explain about a project titled A Deep Learning Approach for Detection of Neovascularization in Fundus Images Using Transfer Learning. This study introduced a novel approach to detect the neovascularization in fundus images. By leveraging the deep learning techniques, initially a collection of fundus images featuring the neovascularization is gathered. These images undergo the pre-processing and subdivided into patches suitable for network training. Various trained convolutional neural networks of CNN, AlexNet, ResNet 18, ResNet 50, Inception ResNet V2, DenseNet are assessed for the effectiveness in detecting the neovascularization through the transfer learning. The implementation and training process of these networks are thoroughly explained. And further, the study presents a proposed method that combines the ResNet 18 and the GoogleNet using the transfer learning. Patients diagnosed with diabetes face the risk of developing a retinal disorder known as proliferative diabetic retinopathy. Neovascularization, characterized by the growth of abnormal blood cells on the retina, is a prominent feature of PDR. If left undetected and untreated, this condition can lead to the blindness. Traditionally, image processing techniques have been utilized to detect the neovascularization in the fundus images. However, these methods can be challenging due to the irregular growth pattern and small size of neovascularization. To overcome these limitations, the project proposes a neovascularization detection method based on the transfer learning. The technique utilizes a pre-trained model as a starting point for training a new model, thereby saving the time and effort. The study evaluates the four pre-trained convolutional neural networks models like of AlexNet, ResNet 18, ResNet 50, Inception, ResNet V2, and DenseNet. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, we import the necessary Python libraries and frameworks required for the deep learning project. These include the TensorFlow and PySword for the implementing of neural network, image processing library for handling the fundus images, Flash for creating the web interface, and other essential libraries for data manipulation and visualization. And the second one is exploring the dataset. The dataset for the neovascularization detection in fundus images is crucial for training and evaluating our deep learning model. We explore the dataset to understand its size, structure, and distribution of images with the neovascularization, which is essential for the model training. And the third one is image scaling and processing. Before feeding the images into the deep learning model, we process them to ensure a consistent and optimal input format. This step involves scaling the images to a standard size and applying any necessary image processing technique like normalization, data augmentation to improve the model generalization. And the next one is split the training and the testing data. To evaluate the performance of our model, we split the data set into the two sets, a training set and a testing set. The training set is used to train the deep learning model, while the testing set is used to evaluate how well the model generalized to unseen data. And the next step is building the model. In this phase, we build the multiple deep learning models, and the first one is Inception ResNet V2. It is an advanced deep learning architecture that combines the ideas from the Inception model and the ResNet. It is known for its efficiency in extracting the complex feature from the images, making it suitable for the tasks like neurovascularization detection and the fundus images. The model's depth and structure allow it to capture the intricate patterns effectively. However, due to its complexity, training Inception ResNet V2 may require that significant computational resources and time. In this project, we evaluate its performance in detecting the neovascularization and assess its potential advantage over the other methods. And the second one is DenseNet. DenseNet is also a deep learning architecture that stands out for its dense connection between the layers. It promotes the feature reuse and the information flow, leading to the highly compact and efficient models. TenseNet can effectively learn from the smaller data set, making it suitable for the medical image analysis tasks like neovascularization detection. Its ability to elevate the vanishing gradient problem and improve the gradient flow facilitates the faster convergence during the training. In this project, we explore the DenseNet performance and consider its particularly the scenarios with the limited data. And the third one is ResNet 50. ResNet 50 is a popular variant of ResNet architecture which introduced the skip connection to address the vanishing gradient problem. This design allows for the deep network while avoiding the degradation issues. ResNet 50 has demonstrated the remarkable performance on various computer vision tasks and is widely adopted for the image classification. And the next one is ResNet 18. ResNet 18 is a smaller version of the ResNet architecture designed to have a fewer layers while retaining the advantages of the residual connection. It strikes a balance between the model complexity and the performance, making it more computationally efficient than the deeper variants. ResNet 18 has shown the excellent result in various image recognition tasks and is well suited for scenarios with a limited computational result. And the next one is AlexNet. AlexNet is one of the pioneering deep learning models that gained the popularity. It features a relatively shallow architecture compared to the more modern models but as groundbreaking at the time of its introduction. In this project, we explore its applicability in neovascularization detection and investigates its performance compared to the more recent and the deeper model. And the next step is training the model. With the model selected and implemented, we process to train them using the training dataset. This step involves passing the training images through the deep learning model, computing the loss function, and optimizing the model parameter using the technique like stochastic gradient descent. And the next one is user gives the input. To create a user-friendly interface, we utilize a Flask web framework. Users can interact with the system by uploading the Fundus image and providing the real-time for the neovascularization detection. And the next step is the given input is pre-processed for prediction. When the user submits an image, it undergoes the pre-processing similar to the training data, including scaling and the normalization to make it compatible with the deep learning model. And the next step is trained model is used for prediction. The pre-processed user input is then fed into the trained deep learning model to the models process the input and predict the presence of neovascularization and the fundus image. And the last one is final outcome is displayed. The predicted outcome indicating the detection of neovascularization and its location and the fundus image is displayed to the user through the web interface. This provides the user with valuable insight into the potential retinal disorder, facilitating the early detection and the appropriate medical intervention. And the next step is of and the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The data folder containing of the folders within it containing of the retinal images within it. And the sample folder containing of various images that will be used to check the performance of the model. And the static folder containing of the various folders like CSS, JavaScript, images, uploads and bootstrap files within it. And the template folder containing of the HTML documents, it typically include of footer, home, index, sign-in and sign-up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as handle the server-side operations, processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And these are the model H5 files which contain the algorithm's information, and it loaded into the project code during the runtime to utilize the trainer model for the various tasks, such as making the prediction on the new data or performing the specific operation. A notebook is an IPYNP file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in individual cells, making it a popular choice for the data science. And the signup.db is a file appear to be the database used to store the user information. And for the execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here we need to write the command cd space and paste this code folder path. By this, it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command, that is python space app.py. By using this command, it will execute the Python script to perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running of app.py file, the Flash framework will host the application locally at the default address. Like this, we need to copy this local link and paste it on any of the web browser of our choice. And I prefer to use the Google Chrome and pasting this link and then click on the open button, click enter button. Here it will redirect it to this page containing of some details of that project and project name. And here click on the sign up button. It will redirect it to the sign up page containing of some necessary details that are need to be filled out to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page containing of username and password. I'm entering those details of username and password and then click on the sign in button. Here it will redirect it to this page containing of the choose file and upload buttons. And click on the choose file button. Here it will redirect it to this folder containing of various images within it. I'm selecting one and then click on the open button. And then click on the upload button. Here it will redirect it to this result page and predicted as the result is of moderate condition. And then by using the try again button, here we redirect it to this index file and then click on the choose file button. And then here I am selecting the one image and then click on the open button and then click on the upload button. Here it redirected to the result page and predicted the result as of healthy eye. In this way, we can predict the eye of by using the Fundus images using the transfer learning. And in conclusion, the project proposes a transfer learning approach for detecting the Neovascularization and the Fundus images. The performance of the proposed approach is compared to 4 pre-trained CNN, AlexNet, ResNet, ResNet 50 and the Inception ResNet V2 TenseNet. The results show that the proposed approach outperforms all the other approaches. This is because the proposed approach is able to extract the more features from the Fundus images, which leads to the more accurate detection and the neovascularization. The proposed approach is also compared to another deep learning approaches that use the pre-trained CNNs for the feature extraction and SVM for the classification. The results show that the proposed approach is also superior to this approach. This result of this project demonstrates that the transfer learning can be used effectively to detect the neovascularization and the Fundus images.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.